Okay, so our first discussions today, we want to talk a little bit about the domain of a function. The domain of a function. Well, simply stated, we concentrate our thinking here to the real line, the real numbers. And when we consider the domain of different types of functions, we're basically considering those x values that if we substitute into our function, it produces an output, meaning that we have an answer that makes sense. So when we're searching for the domain, we're searching for all values of x that we are allowed to substitute and to evaluate into our function. For example, the first type of function that we want to take a look at is the functions, the linear functions. F of x equals mx plus b. Now, if you recall from algebra, the slope-intercept form of a line is y equals mx plus b. So all linear functions that is of this form, where m and b can be any type of integer, can be any real number, where the m and b are real numbers, well, all linear functions are defined everywhere on the real line, meaning you can go and get any x in the universe that you want to, any value of x, substitute it into your linear function, and it will give you an output. For example, let's take a look at a real small example here. Let's say f of x is equal to 2x. Now here, this is a linear function where our m is 2, and of course our b is 0. So what we're saying here is that the domain for this function is all real numbers, meaning for every value of x that you give me, I can substitute it into this equation, and I can actually get an output value. There are no x values that will cause this function to be undefined. So all linear functions, and that's a great technique that you take into the ACT. If you're positioned or asked a question about the domain for a linear function, where it's hands down, no thinking. All real numbers, every x value works for the domain of real numbers, unless we have a very specific situation where our domain is restricted. So f of x equals 2x, the domain is all real numbers, and that's what you will put. So some notation, capital D with the colon, or you can just simply write domain. It doesn't really matter. Domain is all real numbers. Okay? Now, like I said, for instance, perhaps our domain is restricted. Let's say that we're given the function, the same function, f of x equals 2x, but yet now we're only defined, x is only defined between -1 and 5. See here, our domain now is specified. It is very restricted. It's telling you that x only works for values that are greater than or equal to -1 and less than or equal to 5. So in this situation, although it's a linear function, because the author, whoever prescribed the problem, has restricted the domain, you can't say that the domain for this function is all real numbers. It is only those values that are specified. Okay?